Hi, welcome back to Leetcode. So in this video, I'm going to discuss the third problem from today's weekly contest 481. The problem name is minimum swipes to avoid forbidden values. So the problem statement is you are given two integer arrays nums and forbidden, each of length n. Okay, both are actually equal size. Okay, you may perform the following operation any number of times, including 0. Choose two distinct indices I and j and swipe nums I with nums of j. Okay. Return the minimum number of swipes required such that every index I, the value of nums I is not equal to forbidden I. Okay. If no amount of swipes can ensure that every index avoid its forbidden value, return -1. Okay. So let's see the example 1. So 1, 2, 3 and forbidden array is 3 to 1. So our nums array is 1, 2, 3 and forbidden array is 3, 2, 1. Alright, now our target is that swipe in do some operation on the nums array. After that, such that nums of I not equal to forbidden of I. That means at the same index I, the character present in the nums array and the character present in the forbidden array both should be unequal, means different. Both should be different, right? That means here you can see that this is 1, this is 3. So this is already, we don't need any swipe here, right? Both are actually already different. This is 2, this is 2. So okay, we need to do some swipes, right? We need require. This is a requirement. Still we don't know that this is feasible or not, right? Next is this is 3, this is 1. So this is already different. So we don't need any operation here. Now you can see that this character I have to swipe that, right? We have to we have to do some operation on this current character too. Now to do this, how many operation we need? Here you can see that we need to swipe at least here. So for that we actually need one operation. So our nums array will be look like 2, 1, 3 and forbidden array it will look like 3, 2, 1. Okay, after this, after one operation you can see that after one swipe, here actually you can also cross check this. This is 2, this is 3, both are actually different. This is 1 and this is 2, both are actually different. This is 3, this is 1, both are actually different, correct? So here actually you can say we actually achieve that target, that or actually each index I character present in the nums array or the number present in the nums array is different from the number present in the forbidden array, correct? So after one operation we can achieve that. So for this example 1, our answer will be 1, right? Yes, output is 1, correct? Now let's see this example here. Actually they mention that our output can be -1. So actually they mention that if no amount of swipes can ensure that every index avoids its forbidden value, return -1. So what can be our case actually for -1? Our answer is -1. So will be our answer will be -1. Suppose we actually have 7, 7, 8. Okay, and we actually have here actually 5, 5, 7, 7. Okay, this is our nums array and this is a forbidden array, suppose. Okay, so now this character, this is already different. We do not need to swipe this. This is already different. Okay, this is, we need to swipe this, correct? Because both are actually equal. So this is already different, so we do not need to swipe this. So which character we have to swipe? 7, correct? 7, we want to swipe 7. Now, or actually I can place this 7 I can place this 7 here, I can place this 7 here, or I can place this 7 here. 3 positions are possible. N minus 1, total length is 4, 4 minus 1, 3 places are possible. Now, here actually you can see that how many 7 is present in the forbidden array? 2. So, our target is that nums of I should be not equal to forbidden array of I. Correct? This is your target. We want to achieve this, that our whatever that index present in the I, that number should be different from the forbidden array. Now, there are 3 7 is present, correct? And 2 7 is present in the forbidden array. So here actually I can place the 7, or actually 7 not equal to 7. These two places are possible. So let's draw this again, 7 7 7, and this is suppose different character, so that's why this is empty now. Okay, and in the forbidden array, in the two places we actually have 7, correct? So I can place 7 here, or in this index 0 or 1. Then actually if I place 7, then actually index I, nums of I, it will be different from forbidden I, correct? But is it possible? Here actually we have 3 characters, and we have 2 places to place 7. Suppose I have 7, we have not swiped this, but if I suppose swipe this here, again this 7 will be conflicting, right? Both will be equal. And if we keep this in this way, both will, again it will be conflicting, right? Both will be same. So for such situation, our answer will be -1. If we can do any number of swipes, still there will be at least one place where actually we will get some number which actually is equals to the nums are equal to the forbidden I. Clear? Because in the nums array we have 3 7. Now we want to place in such a way that nums of I not equal to forbidden I. And where actually I can place, we cannot swipe this array, this forbidden array. So we actually have 2 place only, 2 index, where actually I can place 7. But we have more than that. We need actually we actually have 2 free places, but we actually have 3 7. So at least 1 7 will be present, or actually both at the nums of I equal to forbidden I. Got it? So frequency in nums array, suppose number I, if it is greater than n minus frequency of forbidden array of nums I, if it is greater than that, then our answer will be -1. This is clear? In the nums array we have suppose x number of number 1, suppose. Okay, we have seen the number 1 x times in the nums array, and in the forbidden array we actually have y times. Okay, and so what is the free spaces, or actually I can place this current number 1, or actually there will be no conflict, that will be n minus y, correct? Total position it is actually n, and y position already number 1 is present, so the free places to place number 1, it is n minus 1, and we have seen x number of times in the nums array. So if it is x greater than n minus y, so our answer will be -1. I hope this this situation or this case actually is clear. On actually our answer will be -1, correct? If the frequency of number x is greater than the n minus y, then it will be actually -1. This is clear? So, and case 3, it is actually our answer will be 0. And if there is no diff, so if there is no equal number in the index I, correct? So we have checked the nums array, and we also check the forbidden array. Now you compare with this particularly, you will check that if there is no such situation, or actually our number actually is equal, that time we do not need any swipe, so that time our answer will be 0. So 3 cases actually we can actually have. One is actually our case our answer will be 0, there is we do not need any swipes, and case 2 is that actually our answer will be -1. So I hope the condition is clear, that if the frequency of this statement is clear, I think. So if you found this still not clear, please try to draw one example. You can also take the 7 7 in the and 8 7. So here actually you can see that 7 is present in the two places, two indexes, and we have actually free places. For example, I can place 7, it is still only 1, but still there will be one index, or actually 7 will be equal to 7, correct? So for this situation our answer will be -1. Clear? The case 2 and case 1 is that when it is feasible, so our answer will be the total number of conflicting position, suppose x number of conflicting I have seen, and the frequency or the maximum frequency we want to swipe. Why actually we want to calculate the maximum frequency? Let's discuss this again in depth. The case 1, so this is feasible case, right? Or actually we can have some like limited number of swipes. So suppose we got that x number of position we have to swipe, total x number, okay, and we have computed that what is the maximum frequency of the character we want to swipe. Suppose this is also y. Suppose let's take the example. Suppose 1 1 1 2 3, and this is suppose 1 2 3 4 5. Okay, now how many positions actually we have to swipe? We don't need to swipe here. Yes, we need here, we need here, we need here. Oh, sorry, this is actually different. We should actually same, right? So 1 2 3 4, both are actually equal, okay? Okay, 1 1 1 2 3 4. So here actually also this is the norms array and this is the forbidden array. Okay, so now we have to swipe this, we have to swipe this, we have to swipe this, and we have to swipe this also, we have to swipe this also. So all number we have to swipe. So total swipes actually we have to do 6 position actually we have to swipe. So if both actually, if two different character we have to swipe A and B, then it will fix two position at the same time, only one operation. In one operation we can fix two position, correct? So that means here actually you can see that if I swipe this position, so this will be 1 1 2 1 3 4. Okay, and now if I want to swipe this, so this will be 1 3 2 1 1 3 2 1 1 4. Okay, and now still we have to swipe this. We have already fixed this 4 position. Now we have to swipe this. So this will be 4 3 2 1 1 1. Okay, so now you can see that our forbidden array was 1 1 1 2 3 4. All the positions we have different number: 4 1 3 1 2 1 1 2 1 3 1 4. So this is actually valid, right? So how many swipes I have done? 3. Here actually I have done 3. Here actually I have done one swipe. Sorry, it is the first swipe, this is the second, and this is the third time. So total this actually we will get x by 2, x plus 1 by 2. Why actually x plus 1 by 2? X is the total number of position actually we have to swipe, and that is x plus 1 by 2. Why actually by 2? Because we have already explained that if both the characters are different, so those two positions will be fixed at the same only in one operation. So that's why by 2. Okay, and why plus 1? Because it is possible that we have actually only one position we have diff. Okay, suppose this is a situation 1 2 in the nums array. In the forbidden array we actually have 1 3. So this position we have to swipe only, so our x value will be 1. Okay, so how many swipe actually I have to do? So if I do only 1 by 2, it will give us a 0. But if we need to do at least one operation, one swipe, so that actually I will get from the ceiling value. We do the ceiling of this, so it will be 1 plus 1 by 2. This is ultimately 1. So at least one operation I need. So that's why x plus 1 by 2. Clear? Now this is one again case is possible where actually our frequency will be like if you actually have two character AA. Okay, then how many actual operation we need to fix this? Two operation. Why two operation? If both the character actually different, then actually I can fix b comma a. But here actually both the character actually equal, both the number actually is same. Then we need to two operation. Why? Because one operation I can fix this with a different position, and I will fix this with a different position. We cannot swap this in between. Correct? Suppose we have taken another number 111 2 3 4 111 sorry 4 2 3. Okay, so I have to swipe this number, I have to swipe this number, and I have to swipe this number. Okay, it is already different, this is already different, this is already different. So our x will be 3 position. I got the conflicting type, right? Or actually both are actually equal. Now if I do just 3 plus 1 by 2, our answer will be 2. Is this correct? No. Why? You can just also observe this. Try to do in two operation. So first of all, swipe this with a different character, because if I swipe between 1 and 1, there is no meaning, right, to swipe this. So that's why a string or number will be look like 2 1 1 1 3 4. Okay, this is one operation, one swipe. Now still we have to swipe these two, or still two position is still left. So I have to swipe this with this. So number array will look like 2 3 1 1 1 4. Okay, and still we have to swipe this number. So this will be swiped with this number. Okay, this will be 2 3 4 1 1 1. This is clear. So how many operation I have done? I have swipes 1 2 3 swipes. So that is the maximum frequency of the character we have to swipe. So that is the frequency of 1, that is 3. Got it? So I have to take the maximum of this, maximum value of frequency of the character that we have to swipe, or x plus 1 by 2. Clear? The case, this case number 1 is clear. Honestly, it is feasible that with some limited number of swipes we can actually achieve the target, or actually nums of I not equal to forbidden I. So we have to compute the why. I've already explained why actually we need to know the frequency, maximum frequency of the character who we have to swipe, and also the x plus 1 by 2. X is the total number of position we have to swipe, and plus 1 by 2. This is case where actually both the character actually it is different. So in one operation we can actually fix two position. But if the character is same, that time actually we need to calculate the maximum frequency of that. We need to know that. So that will be the maximum frequency. Got it? If both are actually equal, AA. Got it? So now what is the code? If any doubt, you just comment on that. And now try to understand the code. So I have taken 3 map actually for each what actually I have stored here 1 2 3. Yes, how many times still I have seen this number? Why actually we need to know this? Because in the case 2, or actually the situation is -1, that time we need to know that the frequency of number present in the nums array, it is greater than, this is the case or not. Frequency of the any number present in the nums array, it is greater than n minus the frequency of number present in the forbidden array. If it is greater than that, then actually our answer will be -1. That is not possible. So that's why I have taken 2 map. This is the map 1, okay, and this is the map 2, to easily compute to know the frequency of any character, any number. Okay, and why actually third map is to in the case 1 we need to know the frequency, right? That for which number actually I want to swipe. So what is the maximum frequency for that character? Okay, so that will be stored in the map 3. Okay, to know the maximum frequency we have to swipe. That is not the frequency of the character, it will be frequency of the character we have to swipe. Correct? So that's a 3 map. Map 1 is store the frequency of any number present in the nums array all over. Map 2 is to know the frequency of any number present in the forbidden array, and map 3 is that the number present in the nums array, we have to swipe that. Means nums of I equal to forbidden I, that we have to swipe. So we have to store the frequency of that character. So that will store in the map3. So map3 will store only the number only for the conflicting type, right? If the nums of I equal to forbidden I, then only that number will be frequency will be stored in the map3. Otherwise, it will not be stored. Okay. So n is the total array length, nums of size, and diff is that. So in the case 3, we have mentioned that when actually our answer will be 0 if there is no conflicting position, or actually nums of I equal to forbidden I. So that time we can directly return 0. So that's why this actually easily count the total number of conflicting positions I have seen. So diff will be 0. And now iterate the input array. Okay, means the nums array from index 0 to n minus 1. So now map 1 and map 2, this two frequency will be increased by any way, whatever the number is present in the nums of I and forbidden I. Okay, frequency, this is the global, or you can say that all over the frequency of character or number, it is to the frequency of that. So that's a map of nums of I plus plus, and map of 2, it will store the frequency of the current number present in the forbidden array. Okay, now whenever conflicting situation is that if the nums of I equal to forbidden I, so if this is the situation, then actually we will increase the diff, that means the conflicting type. So I'll increase the frequency to handle the case 3, or actually we have to return 0. We have to know that is there any conflicting type or conflicting position or not. So we can easily find out that. So diff will be increased if there is any conflicting type, and also the frequency of the current character or current number we have to swipe from the nums I, because we can swipe only on the nums array, right? So that's why nums of I present, or whatever the number present in the index I, that will be store the frequency of that in the map3. Got it? Now after this for loop, we can see that is there any conflicting position or not, and also in the map 1, in the map 2 and map 3, we can easily we have already pre-compared the frequency of each number present in the nums array, in the forbidden array, and in the map 3 we can easily find out the frequency of the character that we have to swipe, total frequency that we have to swipe only in the conflicting position. So if it is already valid position, that means nums of I not equal to num forbidden I, that time we do not need to swipe that position, and we will not calculate or count that position. Okay, we only count if the nums of I equal to forbidden I, that is the conflicting position. Okay, so in the map 3 also we will populate that only. So after this we will see that do we need to any swipe or not, so that we can easily find out from that the diff value. If diff value is equal to 0, so return 0. Okay, now the case is that when actually our answer will be -1, or we have some feasible solution or feasible number of swipe. So what is the condition for -1? -1 condition is that I have already explained that the frequency of number present in the nums array, that is suppose x is greater than n, total both array length is same, so n minus y is the frequency of number present in the forbidden array. If that is greater than this, so that time at least we should always we will have some position where actually nums of I equal to forbidden I. So that's why I will see that. So I am just iterating on the map 1. Okay, in the nums array I will see that what is the frequency of this current number in the forbidden array. So how we can easily find out this from the map 2. In the map 2 I am searching the current number I dot first. Okay, and what is the free places for this current number? N minus the frequency of the current of this current number in the forbidden array. If I subtract this, I will get the free places, or actually I can place this current number, or actually nums of I will be different from the forbidden I. So if the frequency of this current number in the nums array I dot second, if it is greater than n1 is the free places in the forbidden array, or actually I can place the current number. So if it is greater than that, return -1. Clear? I have already explained many times why actually our answer will be -1 for this. Okay, next is the case 1, or actually we have some limited number of swipes. So for that we actually need two things, that is the maximum frequency of the character that we have to swipe, and the total number of actually conflicting position. So that is Ix is already calculated, that is the diff, ultimately diff is already calculated, right? That is the whenever we have got some position, or actually nums of I equal to forbidden I, we have increase the frequency or the increase the value of diff. So this diff actually indicate the total number of swipes or total number of position we have seen the conflicting type, right? So now we have to calculate only the maximum frequency that we have to swipe. So that actually I will easily get from the map 3, right? So I will just iterate from the on the map 3 and I'll check what is the maximum frequency I have seen. Okay, in the max frequency this will be stored, right? And ultimately our answer will be what for this case? Total number of position we have seen the conflicting type plus 1 by 2. This is the case where actually we have two criteria different, a comma b. We can easily swap that and we have fixed both the position at the same time. So then the total number of operations will be d plus 1 by 2 and the maximum frequency of the character we have to swipe. So we have to choose the maximum of out of these two. Got it? I've already explained why the maximum of this. Got it? Maximum frequency is to handle the situation where actually all the characters is same, a comma a. If I want to swipe this, so that time we need to two swipes, right, to fix that two position. So I hope this is clear. I have shared this code in the description. You can check that, and if you have any suggestion, any doubt, you will comment on that. I'll try to resolve that also. And if you found this video useful, please like the video, and if not subscribe, please subscribe channel. See you in the next video. Bye bye.